Okay, so if I take that data and highlight it and copy it, I can go to StatKey and I would go to the one quantitative variable. And one reason I like StatKey is it does a bunch of stuff quicker all at once. But if I want to configure things personally, because StatKey doesn't give you a lot of options, all I do is paste the data in. And I have a header, so I leave data has a header row checked, but I don't have an extra column in front saying whose house each of these prices goes to. So I'll uncheck that one. And if you don't have the right boxes checked, it kind of messes things up. So I can use their quick histogram builder. And when I point to one of these columns, it tells me the boundaries in the bottom right over here. And so this column right here is houses between 329,000 and 450,000. And in which city I am in here? I grabbed the Pendleton, no, which one did I grab here? Pendleton data, okay. So this was the Pendleton data. Where'd you go? There you are. And you can always adjust the number of boxes, however many you want. And just kind of play around with that. 10 looks like. Yeah. And one problem with StatKey is they don't show this, they show these scales on the bottom, and the center of the number is where that number is, but they don't show the boundaries of the boxes. So that's one downside. But you can get a quick look at the data and decide how many groups you want. And then they give the summary statistics here, and then they have the box plot maker over here. Okay. So just for fun, let's see. I'm going to pick a different data set because I want you guys to explore this one. So I'm going to get out of there, get out of there. Let's pick a new data set. Anybody have any questions they wanted to ask about last week or this week? You just want to see another overview of stuff? I'm at your service. Don't all speak at once.
Hey, Mr. Parker.
Whoa.
After the end of class, would you be able to help me submit my histogram?
Oh yeah, what happened there?
So when I try and submit it,
Yeah.
it won't let me select both of them and turn them in. I can turn one of them in at a time, but once I turn in the second one, the first one disappears.
It's still there.
So I tried to put both of them on one page, and that's when you got all of them. But for some reason, it went from Google Docs for Google Sheets to Excel. That's the one you got.
So it's originally in Google?
Yes.
Okay, so then what you would need to do is, so let me just bring up an example. Let's take this, my COVID-19 page. The Oregon Health Authority has been collecting data on cases throughout the state. And they had this frequency table on their website. And I was like, oh, frequency tables, we're covering that. So I took their frequency table and I copied and pasted it into my spreadsheet so that I could turn it into a chart.
Yeah.
So, you know, it looks like the majority of cases are people from 30 to 70 years old. And so I also made a box plot, and you'll get to read about box plots in this section. So if I wanted to turn this in as my assignment, then I would go to the share and make sure it's set to share with other people. And then once I do that, I just want to copy that shareable link. So once you copy the shareable link, then in that assignment, so let me just go in under student and put it in there. You're not going to upload anything. You're just going to give.
Okay.
So then let me go to the histogram assignment. And then in the histogram assignment, and here you could submit, like if you had multiple Google Sheets, you could submit them all. I think it's this one right here, right? Activity 7, 1B. Yeah. So then from submit, you would choose, there we go, text entry. And you could do one of two things. You could just paste that address in there and then hit enter, and it makes it a hyperlink. Or you could just type something like, here is my Google Sheet, and just like highlight the phrase Google Sheets and make that a link to the address you just copied from Google. So then I paste that in here so that when I click on that right there, it'll take me to that file.
Okay, so then just make 2 of those and then you can access both of them?
Yeah, so then if you had multiple sheets you wanted to share with me, then in the submission, you don't have to do 2 submissions, you could do it in one shot. So you would just come down here
Just
and
do both?
enter the first one and then new line and then enter the next one after that.
Okay.
Yeah.
All right, perfect. Because when I was going to file upload, I would upload one, but it wouldn't let me.
Yeah, so with the file upload, if you have multiple files to upload, then you put one in and submit it, then you resubmit. And when I see from you, I see that you submitted 1, 2, 3, 4, however many times.
Okay.
Yeah, so if you do have separate files to submit and they're uploadable files, you'd have to do them one at a time, and I'll see that you did multiple submissions.
Oh, okay. I can do it like that too?
Yeah. So yeah, when I look at yours, like if I leave this and I look you up, let me pull this out of the way for a second and then look up. I should have done it for test student. Jimmy. There you are. Yeah, so when I see yours, I see that you have a whole bunch of different submissions, and then I can look at each one of them.
Okay.
Yeah, so please, if you had a submission problem or you didn't submit yet, please submit those as soon as possible so I can get those graded and back to you. I'm going to be working on grading some more tonight. All right, other questions, things you want to talk about, things you want to do? And I'm just looking back and forth from the chat screen to the regular screen. Nobody's asking for anything. Do we just want to end early, or do you want me to do something? Somebody help me out here. So you guys got to get your reading done today, but I think almost everybody got it done early because I had the wrong date in there. Sorry, and good job. Okay, well, no one's asking. I'm going to do something for fun then. I am going to, that's not the data set I wanted. What's a good data set to work with? How about uninsured rates? Uninsured. Let's try that one. Okay, so this is a fun one. So the census is going on now. I don't know if any of you have gotten to fill in your census. I did mine last week. It was pretty exciting because I'm contributing to the nation's math. So from the US Census Bureau, I found some data about in a given state, what's the percent of people that don't have medical insurance. And so Oregon, for example, here, let's blow that sucker up, has 6.2% in 2016, 6.2% of Oregonians did not have medical insurance, and they have a margin of error here of 0.2. And so the margin of error just means this could be off by it's either 0.2 too high or too low. So that means the range that they think is somewhere between 6.0% up to 6.4%. And I just included the margin of error because it is an important idea. We'll talk a little about margins of error in the next section. They're related to a thing called a normal distribution. So anyway, it varies from state to state. So like Oklahoma is in rough shape. There's almost 14% of people are uninsured in Oklahoma. Some states are better off. Like I grew up in Rhode Island. Only 4.3% of people in Rhode Island are uninsured. And it just varies all over the place. Texas is pretty bad in terms of people who are uninsured. Vermont is pretty good. So if you're concerned about insurance and you're shopping around for a new state, this might help you pick it because apparently some states are easier to get medical insurance than others. So what I'd like to do is look at the distribution of these numbers, because that's a lot of numbers to look at. It's hard to wrap my mind around it. So the way we do that is we make some charts and some graphs. So I'm going to use a spreadsheet to do that. It behaves pretty similarly in Excel, but Google Sheets is my favorite. So the first thing I think I'll do is make a frequency table. And to do that, I need some information about this data, like what's the max, what's the min, and so on. And so I'm just going to ask for those. So I want to know what's the min. I want to know what's the max. Based on those, I can get a range. And I went over this in my video about making frequency tables from last week. So equals min, and highlight your data. Now I'm ignoring the United States line because it is not a state. It's a conglomeration of all of these. So that would be not appropriate to put in there. And max, similar, highlight numbers. And Google's a little bit more forgiving. If you forget to type the closing parenthesis, Google adds it for you, but Excel freaks out on you. Range is the difference between the max and the min. So I can see we have a low of 2.5% and a high of 16%. So when I make up my frequency table and I decide on my groups, so I'm going to have a column for group maxes, groups, and frequencies. Google and Excel will make quick histograms, but I also want you to be able to make frequency tables, and the quick histograms don't come with frequency tables. So let's see, I need to get from 2.5 to 16-ish. Sometimes I kind of play around with how many groups I want or the group width I want. Let's suppose I want 10 columns or 10 groups. So that means to get the width of a group, I would take the range and divide by 10. And this says you should have a range of about 1.4. So maybe I'll go by twos. So then the first group could be, say, from, how about, let's see, I got to get 2.5 in there. So maybe from 1 to 3. And then, okay, these have decimals though. So how do I want to do that? This next one would be from 3.1 up to 5. Oops, I'm typing these in the wrong spot. And it made that one a date. One problem with spreadsheets sometimes. So let's say I want a max of 3 there and 5 there. So that gives me a width of about 2 instead of 1 or 1.4. Just fill that down. And I need to catch the biggest one, and 17 is big enough for the max there. What do my groups look like? Well, the second group would be after 3. These numbers have 1 decimal point. So that means the second group would be 3.1 up to 5. So the previous one should be 1.1 up to 3. So these are the human readable versions as opposed to just what the computer needs. And I usually don't type these till after I see what the frequencies look like. So I'm going to wait on typing more of those. To calculate the frequencies, if you're an Excel user, you highlight each adjacent cell to a group max +1. And then you just start typing equals frequency. Highlight your data, comma, scroll back up and highlight your groups. Close parentheses. And in Excel, you have to do Control-Shift-Enter. In Google, it's just Enter. So those are my frequencies there. And I just want to get a graph of those to see if this looks good. And usually I do a couple of these. So insert chart. And maybe it'll give me a bar chart. Kind of messed that up. Use column H as labels. There we go. So these are up to 3%, up to 5%, up to 7%, 9%, and so on. That looks pretty nice. I'm going to do one more just for fun. So let's scoot maybe underneath should be fine. Maxes. So again, I was playing around. If I wanted 10, it said to make the width 1.4. 1.4 is kind of a weird number. I could go 1.5 or even down to 1. Let's see, when I went with 2, I got 1, 2, 3, 4, 5, 6, 7, 8 columns. 8's kind of nice. If I went with 1, I would get like 16, which might be too many columns. The book recommended you go somewhere between 5 and 15 groups, and over 20 is just too messy. It's too many columns. It looks like crap. I think I'm going to try, I guess I could try 1 and see what happens. So then I would want to go 3, 4, 5, 6, and I got to get up through like 17. And then I'm going to skip over in case I want to type pretty labels for the frequencies. I'm just going to abbreviate. And remember, if you're an Excel user, you first have to highlight all of the cells and then start typing equals frequency. Then highlight your data. Then comma, highlight your groups. And there's a video recorded about this. Close your parentheses. Excel users would do Control-Shift-Enter. Google users just hit Enter. And so if we graph these two, does that look crappy or good? Chart, please. And it totally messed those up. Eek. What did you do wrong, Google? Or did I highlight things wrong? Wow, that's a mess. It's just plotting these numbers. Why? Fascinating. Why did it work the first time? Column chart. Let's choose that version. Oh, it's ignoring the other one. So let's add, range. So sometimes the wizard does not do a good job. Okay, there we go. So I had to add on. That's funky. Look at that. It's got this bimodal thing going on. Mode is the most frequently occurring number. And in this region, things in the 6% range occur just as often as 9, which is pretty often. Well, that's cool. I like that one. I'm going to keep it. All right. And usually I would, these are kind of misleading. 3%, 4%, 5%. This is up to 3%, up to 4%, up to 5%, and so on. So that's what the human readable ones are for, to relabel properly. So this would be 5.1 up to 7. And I usually don't type these in until I like the look of it, because this is a pain in the butt. Don't type it unless you really want to. And then what would be next? 7.1 up to 9. And no, yeah. And then 9.1 up to 11. 13.1 up to 11.1 up to 13. You get the idea. Once you type all of those in, I'm not going to let you watch me do the next one. I'll do that when you're not looking, so I don't bore you to death. 15.1 up to 17. So this will give me a better looking graph because I have prettier labels there. So insert chart. So you needed to do this last week for activity 7 for a set of numbers, and then I need to put in better titles. So this is percent by state. Down here, these groups are really percent uninsured. So make sure you put good labels in. Frequency, my mom doesn't like that word. She would prefer I do something like number of states. So we want to make this readable so that like some magazine might want to print your graph because you did such a nice job labeling it. All right, so that's a better chart than my first one. So I'm going to just delete the first one because I got a better looking one. And then eventually I would go down here and make pretty labels for that one before I submit it, because that's a cool looking graph right there. All right, so that's part of your job from last week, and you're going to get to do that again. Other calculations we're going to do for statistics, and a statistic is just a calculation you do on a set of numbers. I would like to calculate the mean, standard deviation, which I'm going to just abbreviate. And then what else do I need? I would like the quartiles. I'm going to do min again. Quartile 1, the median, quartile 3, and the max. And there's a video in the video section with me doing this stuff on a different set of numbers. So min, I can just copy from above. To copy something above, you type equals and then click on the number. Same with max, equals, rather than retype the max command. Median, command for that is median. Highlight your data. And then quartiles, and I'll explain what these mean in a minute. You need to read about it in the book too. And in Excel, the equivalent one would be quartile inclusive. And highlight your data. And then it wants to know which quartile you want. And you're going to enter 0, 1, 2, 3, or 4. And this is the first quartile. So I enter 1. And then this one down here would be the third quartile. So quartile and inclusive do the same, but inclusive is the Excel version. And again, I want the data, comma 3 for the third quartile. All right. And these numbers right here are what are referred to the 5-number summary. They're the numbers that make a box plot. So let's highlight those pretty. So if I were to take this data set right here and stick it in StatKey, when StatKey makes a box plot, it's calculating those numbers. So in StatKey, I can go to edit data, replace whatever data is there with mine. Ooh, I didn't apparently copy it because that's not data. That's a link to a file. Let's try that again. Control C. There we go. Paste. I do not have a header row, nor do I have identifiers. So uncheck both and box plot. So let's see, min of 2.5, yep, max of 16.6. Median should match my spreadsheet, which Google said was 8. And the quartiles, ooh, that blue is horrible. What was I thinking? Let's go with that. That's a little better. The quartiles won't necessarily match. Excel and Sheets do quartiles different from a calculator, and sometimes that's different from a program like StatKey. So let's see, Google said 5.6 and 9.6. Oh, they agree today. Okay, the quartiles won't always agree, but they should be in the ballpark. The classic way of drawing box and whisker plots based on your textbook is to just draw this line all the way out to the maximum. And StatKey is using a method of checking outliers by extending what's called the interquartile range. And I'm not going to overload you with that right now. We can talk about that next class. So that's a box plot there. If I wanted this box plot to appear with my histogram here, I'd have to do a screenshot. So if you're a Windows user, you would use the snipping tool. And depending on which version of Windows, it's either called snipping tool or it's called snip and sketch. So if you have an updated version of Windows, when you type snip, you'll see snip and sketch is the updated version. I have not updated my desktop in a long time. That's bad on me. And the snipping tool, you would just say, hey, give me a rectangular snip, and it grays out the screen. And then you just draw a rectangle around what you want. And I want to see the box, and I also want to see those numbers at the bottom. And then I would have to save it, give it a name. Let's see, this is uninsured box plots. And to get it into my spreadsheet, I'm going to have to zoom out to do this. I would want to line it up with these numbers as best I can. So in Excel does the same thing. You would go to the insert menu and then image. And I want it to be over the cells. I'm going to browse to upload it. There it is. And then I'm going to have to resize it to fit because I want this scale to match the scale up there. So that's a little tricky. Usually use the corners to do that. So 2 here would line up about there, and 16 should be right in the middle there. So I need to resize Oops, 16 is right there. Okay, so then 14's there, 12 is in the middle there. That's not too bad. So I'm trying to get the lines in my box plot to line up at the middle of the stack because 2 is right in between 3 and 5, and 6 is right in between 5 and 7. So that's not too bad. Yeah, so now I have a box plot that lines up with my histogram. And what we'll usually see is anywhere there are tall stacks, we should see narrow regions in the box plot. And anywhere I see shorter stacks, I should see longer sections of the box plot. And those longer sections could be in the middle. You could have stubby tails in a big wide box. Every data set's different. Show you something else about that. Screenshot again. All right, show desktop. Another snipping. So just an explanation of what a box plot is, and then we'll do just a little more, and we're almost out of time. Or are we? I can't see my clock. Almost out of time. So the way a box plot works again, let me get my pen out here. Hopefully it will work today. Come on. Yeah, bingo, it's my lucky day. So each of these, so right here is one of the marks. That is the min for this data. And I'm just going to extend that line out to look more like a traditional one, like in your book. In your book, they draw that line out to there. That number is the max. This is the number right here they call Q1 for quartile 1. This is the median, not the mean. They're different numbers. And this is Q3, the third quartile. And for example, Q1 is known as the first quartile. First quartile. And it is the position in the data set such that 25% of the values are at or below that point. So my quartile 1, let's see, what did StatKey say? It says it was 5.6%. So Q1 is 5.6. So in this stretch from the min up to 5.6, 25% of the states fall into this category. They're somewhere between the min, which was 2 point something, and 5.6. And between each of these numbers, so from the first quartile 5.6 up to exactly 8, the median, guess what percent of my data lives in this range right here? You got it, 25%. Because the median is also the second quartile. So that's an interesting thing about the median. The median is equal to the second quartile. 2 quarters means 50% of data. Second quartile. And it's also known as the 50th percentile. And in this case, the 50th percentile is 8%. 50% of the US states and regions have an uninsured rate of 8% or less. And then in this next section between, I think this one over here was 9.6, if I remember right. And that looks right on the screen. And the max was 16.6. So from 8 up to 9.6%, another 25% of the values live in there. And then finally from 9.6 all the way out to 16%, that's another 25% of the data. So this is the first quarter, the second quarter, the third quarter, and the fourth quarter. And the quartiles are cuts that you make through the data set to mark where the first 25% stops. Then the median is a cut where the second 25% of data stops, and so on. So the quartiles, which a median is a quartile, actually the min is too. The min is known as quartile 0, and the max is known as quartile 4. So the max would be the place where 4 quarters or 100% of the data is at or below. Okay? And those 5 numbers form the box plot. And they just give you an idea about how the data is spread out. So 50% of states have uninsured rates between 5.6 and 9.6%. That's not too bad. But unfortunately, there's a large group of states that have uninsured rates above 9.6%, which is a bit high, I think, but some people don't. All right, other summary statistics. What else can we handle in the last few minutes here? Let's see, I haven't done mean or standard deviation. Let's shift this out of the way a little and talk about those two. Mean is average on a spreadsheet. So I would type average and highlight my data. And in a long list, it's kind of scrolling through. It's a pain. The quick way to get through a list if you're highlighting for a formula is to click on the first one. And then, because I want to go down, Control Shift down arrow will look for the end of the list for me. Just kind of cute. Standard deviation is a measure of average spread, and it's very important you read this section of the book. We'll talk more about what it means next class, but you got to do some playing around with it before we can talk about it more. So STD. The ones you want to use, STDEV in Google Sheets is the same as STDEVS in Excel. They'll give me the same answers, but there's a whole bunch of standard deviation formulas. So we either want the plain STDEV or with a .s for sample, because we always deal with samples, never a whole population. It's too hard to collect a whole population's worth of data, which we'll talk about in the next section. So this says the middle of the data set is 7.9. The median said it was 8. They're close. And the standard deviation is a measure of average spread. And usually what we find is that most of the data is within 2 or 3 standard deviations of the mean. And so I'll try to demonstrate that on this plot here. So we've got about 8 and about 3. So let's do a snip. And this will be the last thing we have time to talk about. New page, please. And this second part is being recorded. All right, so pen. So according to my spreadsheet, the mean, which also goes by the symbol X with a bar over it, which is also called the average. Average, there we go. In this case came out to be 7.9. And I think I'm going to round that to 8 for ease of drawing. The standard deviation, and deviation means, are you different from average? That's deviation. Standard deviation averages out how far numbers are from average. So for example, is Oregon average, right? If I look back at my data here, Oregon is 6.2%. So we are below average. Oklahoma is above average. In this case, it's better to be below average because that means most of your citizens have health insurance. And this is the percent uninsured. So not every group is average. Standard deviation is a measure of how far things are from average as a whole. And we have a standard deviation of about 3. So 8 lies right in the middle of this stack here. So that's my X bar, my mean of 8. And 3 units to the right of that would be 8, 9, 10, 11. And that's right on the edge here, say. Actually, let's put it in the middle. So that would be about 11. So this would be the mean plus 1 standard deviation. That is 8 plus 3, which is 11. If I go 2 standard deviations to the right, if we add another 3 to that, that's going to take us up to 14, which is right in the middle of this stack. So that would be X bar plus 2 standard deviations. And this stuff right here I'm talking about is at the end of section 7.2. So that would be 8 plus 2 times 3, which gives me 14. We can also go the other way. So if I go 3, 1 standard deviation to the left, so 3 to the left, 8 minus 3 is 5. That's about right here. So this would be x bar minus 1s, which would be 8 minus, come on, pen, 8 minus 3. And we could do it again. Minusing 3 again takes me to 2, which is right in the middle here. So that would be x bar minus 2 s's. 8 minus 2 times 3, or 2. And so, so here I'm 2 standard deviations to the left. Here I'm 2 standard deviations to the right. And you'll notice that most of the numbers that we have live in between 2 and 14. And if we look at our table of numbers, let's sort these suckers. These guys, data, sort range, no header row, column B, A to Z. So the lowest was 2.5, ignore the US up there. And if I go up to the edge of 14, that includes Alaska. And how many do I have? Did I ever do a count? I did not. Count. How many regions do I have? The US as a whole, 51. So I've got 50 out of 51. What percent is that? Lie within 2 standard deviations. 98%. So I have 98%. That was 50 out of 51 regions are within 2 standard deviations of the mean. So again, a deviation is just how far is an individual from the mean. So the US is about 1.8% below average. Oklahoma was 13 something, so they're like 5.5% above average, somewhere out here. But if we take into account 2 standard deviations, then we get 98% of this group of numbers are in there. And the book says that for most data sets, at least 75% will be within 2 standard deviations. There's other estimates that say it's going to be more like 95, but every data set is different. I think 75 is just an underestimate to be safe, and 95 is kind of, just kind of depends. Every data set's different. But standard deviations are often a way to kind of compute how spread out is a set of numbers. And this is 3 out of 8. So take the standard deviation, STD, and divide by the mean. That's another special statistic. Why didn't you give me the calculator? Oh, fine. 3 divided by 8, will give me a calculator for that. 37.5%. So this tells me that the standard deviation is 37.5% of the center. And this number right here is called coefficient of variation. And the point of it is to compare 2 different data sets that don't have the same mean, which most data sets don't have the same mean. So you can't directly compare the standard deviation of 2 sets of numbers. You have to consideration the middle, because standard deviation is a count from the middle. Please read the book about this. I have another video explaining a little more about it, and I'll talk about it some more next week. What's the point of all this stuff? The point of all this stuff is humans aren't very good at looking at a long string of numbers and saying, oh yeah, I get it. Like, I don't get anything when I look at that set of numbers. But summarizing with tables, graphs, allows us to draw conclusions about the numbers and then figure out whatever we need to do from there. So these calculations I made are called statistics. A statistic is any calculation you make on a sample of numbers, and this is a sample of numbers here. And then we have the charts to help us describe it. And this, all of this stuff together is called descriptive statistics, which is what this chapter is about. Okay, so that's it for now. Please do the reading, watch the other videos, start the homework, and then hopefully you'll have lots of questions for me for the next class. And in the meantime, I'll grade some more stuff. Unlocked. It is locked and you don't have any passes. Huh. Let me check that out. Hang on one sec. Let me clean up my mess here. That shouldn't lock up the scatter plot assignment. That should be the share your work or the homework. Let's see. So if I go to student view and I click share your work, anybody should be able to go in and reply still. Yeah, so if it's this assignment, you can just go in and hit reply. We go back. And then this assignment, the book assignment. Which one is the book assignment? This one right here. It says you don't have any late passes. That's weird. Everybody should have like 20. What do you see when you go there? Does it say anything like my screen does here?